Okay, so for ratio of areas, all we need to learn is ratio in primary school. You know that as long as they are the same, you must make sure that they are represented by the same number of units. Okay, but before we reach that, what I want you to recognize is how do you find ratio of areas of triangles? All right, so what I want to see is the first kind of question, right? Is the kind of question where the triangles, right? Both of them, right? They actually share a common height. Oops, why like this? Okay, they share a common height. She said that. Okay, so how do you tell? Let's say I have triangle A on the left here, triangle B on the right here. Okay, let's say now I give you, usually you have the ratio, okay? So the ratio will be given by when you find that something is collinear, you quickly go and label or given in the question from here. Okay, so triangle A, let me squeeze it in. So this is triangle A, triangle B. Okay, if I want to find the ratio of triangle A, right? Can you see, right? Okay, I'm just going to put down A over B, okay? So A over B, right? I teach you all the understanding. Then after that, you can just remember how you get there, okay? So how do you find ratio of triangle? Half times base times height. So the base is 1 unit and then the height is h. For triangle B, right, we have half. The base is 2 units and this is the height. So what do I want you to notice from here? I can cancel, divide the u, divide the h. What do you realize though? The ratio just becomes your ratio just becomes half. Okay, so for triangles with common height, right? I'm going to write it over here. Your common height triangles, how do you recognize them? Very typically, usually lah, huh? Okay, they will be side by side. So you can see from the name one. Like for example, this is triangle OAB, then OAC. You see that the first two alphabets are the same, very high chance they are stuck together already. Okay, but you can see from the diagram easier. So for common height triangles, just remember your area of the ratio of the area, right, is as simple as your base ratio. So how do you find your base ratio? Always remember the ones with all your labelings because that's what I tell you all to label for your lines, right? Okay, that's your length. So area ratio, just your base ratio. So once you get better, right? Let's say I want this triangle to this triangle. Hey, so easy. Area is 1 is to 3, right or not? If I want this to the whole thing, right? Easy. 2 is to 3. The moment you recognize common height, everything is very much easier already. Okay? Okay, now the second one. Second one, actually, you all got learn in Sec 3. You all learned this before. This one, you got to recognize your similar triangles. So common shapes to recognize. Number one, this is this one here. Okay, so like that and like that. You have parallel lines. So this triangle similar to the big triangle. What's another common similar triangle looking figures in your vectors? It looks like that. So this triangle is similar to this triangle. So for similar triangles, always remember your area ratio, right? You have to put in a bit of effort, okay? Because this is your geometrically similar figure. You got to take your corresponding length ratio and you're going to square it. That's the thing. Okay, so that's your area ratio. The last step is to just combine everything together. So if it's a one mark question, right, it should be one common height triangle. Two common height triangles. If it's 1 mark again, it could be one pair of similar triangle. Then if it's 2 mark, right, then you need to arrange a little bit of ratio and proportion, which we can try over here. Okay? Okay, so let's see what I have for this one. Okay, I need to label all this, if not I cannot see, okay? So my OB is, I fast forward, yeah, because we did this in the previous question already. So like that, okay? Then GA to AH is equal. So just put 1 is to 1 like that. Okay, so all these are labeling of the lengths using the information here. Remember, if there's a part that talks about collinear, very quickly go and put this in the diagram also. Okay, because collinear also you can find a ratio and you confirm need one. All right. Okay, what's the first thing we want to do? We want to find triangle O what? OHB. Okay, I must draw. I draw with my pencil, okay? So OHB is over here. Okay, this is OHB and GHO. Can you see they are side by side? Yeah, so they're side by side, right? So the thing we have here is that you see, when I recognize it's like similar alphabet one leh, then I know they are quite close together already. Okay, so this is side by side, right? Which one does it look like? Number one or number two? You can think about it. It's number one, right? So number one means that they have common height. So when they are common height, easy. The area ratio will just be my, oops, the area ratio will just be my base ratio. So very straightforward. So go and find out where's your base. So this triangle and this triangle, where's the base? Here and here, lor. So where's the height? The height is here. Can see it not? So this one here, just recognize that this is your common height. So since it's common height, it will be as straightforward as what? Your area ratio is just your base ratio. So 1 is to 2. Easy? Okay, so 1 is to 2. So usually I will just quickly go and pen down, right? 1 is to 2 like that. Alright? Okay, but I believe this one a bit hard to see, so we need to wait a while, okay? Okay, now we want what? We want triangle OHA. Okay, OHA is where? I use a different color. Okay, OHA is over here. Alright, okay. So now you see, wow, suddenly got funny things, all right? But I want you to recognize this one and this one. Okay, can you see the height is over here? That means these two areas same again because it's just base ratio. So you got to turn it around. Sometimes your height may not be at the bottom. We'll turn it around, okay? Okay, so what we have here is that I'm going to first pen down. Oops. I'm going to pen down some stuff here, which is triangle OHA to triangle OAG. Common height, right? So the base is 1 is to 1. Okay? So now, just now, what did we do here? So now we got to see here. This thing just now was 1. This whole thing was 2, right? So just nice I split. Perfect, right or not? It's okay, right? It's perfect, right? Because this one adds up to 2. If it does not, then you do your ratio lah. Okay? So now we got 1 is to 1. So if they just want OHA to what though? To OAHB. There, this one add together, right? So this one just do your puzzle. So this 1 is to 2. Okay? So this one quite straightforward. Okay, so this one using our common height triangles. Can, right? Okay, so I added one more so that we can actually look at our similar triangles kind. Okay, so before you do vectors, this is actually in your Sec 3 geometrically similar. You did it before lah, huh? Okay, I'm not going to prove that they are similar. I'm just going to take it that they are similar. But we're going to do by AA lah, correct? So this one here and this one here similar. Why though? Common angle, corresponding angle. Okay? Okay, find the length of CD. Do I need to find the length of CD? Okay, maybe I need. Okay, I'm just going to fast forward, okay? So what I have here is that this ratio to this ratio will be what though? Let me see. I got 10 over there, is it? CD, 10, 10, 10. Give me a second. Okay, because this is a parallelogram, right? We know that this is also 6.6. Okay, so then I want to find CD, but I must find the whole thing lah, correct or not? So how do I do that? I fast forward. I don't think you all got problem with this. The corresponding length ratio is 8 over 12. Then this is 6.6 over CE. Okay, so I can go and find CE first. Then I'll get 9.9. Okay, so then at least I know that my CD is 3.3. Actually, do I need this? Okay, so I'm just going to continue first, okay? Okay, I just put in here, this one is 6.6. This one here is 3.3. All right, okay, let me put this aside. Okay, so now we're going to find the ratio, right? So you can see from here, this one you must understand, okay? 6.6, 9.9, right? So what's all the corresponding length ratios? The corresponding length ratio, right, is 2 the whole thing, okay, is 3. All right, okay? So we have this part here. So now what we're going to do here is, 2 is to 3. Where's my one more line? Okay, so this is similar triangles, right? So similar triangles, see, it satisfies this shape, right? So if you want to find your area ratio, you must use the length ratio, square the length ratio. Okay, so the first one is what? So my first one is BCD. Oh, so cute, so small here. BCD to ACE, which is the whole thing. All right. So one thing I want to see here is, right, they didn't ask me to prove, but I want you to look at this. This and this is actually the same as this, It's just that it's lying down. Can you see that? parallel lines. So actually these two triangles are also what? They're also similar. Can you see that? So what's their corresponding length ratio? Let's say we use here. Okay, this one similar to this one, right? So this one is 3.3. The whole thing is 9.9. So what's the corresponding length ratio? The corresponding length ratio is 1 is to 3. Because 3.3 to 9.9 can punch in your calculator. But area ratio, what must you do? You have to go and square it. Am I right or not? So your area ratio is 1 over 9 because this is similar one. Can you see that? Okay, so this one unit. The whole thing is 9 units. That means this thing is 8 units because you can just minus away. Okay, ACE. Okay, so let's see what they want for the next thing here. They want BCD. BC, oh, you again. Okay, BCD to BDEF, which is here. All right. So what am I going to do now? Okay, so now, right, I need to do something. What I have to do here is this one to this one. I need to find the ratio first. So what I'm going to do is I do it on top, okay? Later I bring it down. So triangle ABF to triangle ACE. Are you confident that they are similar? Yes, right? So what we're going to do? The ratio is 2 is to 3, right? So you have 2 over 3, but similar triangles, what must you do? You go and square it. So it becomes 4 over 9. Okay? So what do we have? We need to see whether there's anything like repeated or not, okay? So this is 4 units now. Just now, this is ACE, correct or not? You all notice this ACE and ACE? Are they the same? Okay, thank God they are the same. So let's replace all the numbers inside, okay? So now, right, this is 1 unit, okay? ABF is 4 units. Since the whole thing is 9, right, you minus minus, this one here will become 4 lah, correct or not? 4 plus 4 plus 1 is 9 ma. So now you can answer this one already lah. So BCD is 1, and then the other one is over 4. So this is how you make use of your similar triangles and then your ratio after that. Okay? So things to take note for vectors, remember your collinear and remember your ratio. They are quite standard workings one. So you just need to expose yourself so that you know when to use similar, when to use common height. All right, but recognize all these shapes, okay? This one will help you a lot.